Hello, ladies and gentlemen, and welcome to another wonderful lesson with Mr. Wheezy. So, last time we did the trig function tangent. Now we're going to do the other two of sine and cosine. So, maybe if you had a little trouble on the last one, maybe this one, when we go through, it'll help click. I will try to explain a little better where things are coming from, where things are going, and hopefully help clear up some of the confusion from the last lesson as well. So, to start off with the kickoff here, to measure the height of a tree, Bob walked 125 feet from the tree and measured a 32-degree angle from the top of the tree. So, here is Bob. Let's draw this picture out. He's going to be 125 feet from our tree here. So, he's then measuring that angle to that top of the tree, and that's going to be 32 degrees. Looking for this one. So we have opposite over adjacent, which is tangent. So tan 32 degrees equals x opposite over adjacent 125. So tangent of the angle equals the ratio of the opposite over the adjacent. That's where that setup's coming from. From here, we need to get x by itself. So right now it's divided by 125. So to get rid of it, we're going to times by 125. What we do to one side, we have to do to the other side. So first off, I need to change mine over to degrees because I was working on another class. So we're going to do 125 tan 32, close your parentheses. And we get our 78. And we're just going to estimate through around it to the nearest whole foot. Then, so the 78 is why we have 70 feet. So, like I said, tangent's just one of them. The other ones are going to be cosine and sine. So, sine is going to be the length of the leg opposite of that angle over the length of the hypotenuse. So think opposite over hypotenuse is sine. Sine of angle, opposite over hypotenuse. Cosine then is going to be the leg adjacent of A and the hypotenuse. So adjacent over hypotenuse. So if we use this triangle over here, I can slide it there. So sine opposite over hypotenuse. So we're going from A, which is this corner right here. So opposite would be 3, hypotenuse would be 5. 3 over 5. If we're at C, now our opposite would be 4, hypotenuse still 5. Cosine of A, so we're looking for the adjacent. Adjacent side is what's touching it, think of it. So opposite is away, adjacent touches that angle. So 4 over 5. And then cosine, adjacent would be 3 over 5. So you probably kind of notice these are kind of tied together because if we're at A, opposite is 3, where if we're at C, adjacent is 3. So again, you can find these trig functions no matter what angle you're at, except for at B, because that's a 90. But at either one of these, you can still find any of the information you need. They all tie together. So, just like with the tree, we can go through and we can find solutions here, like we have a 20-foot wire supporting the pole that forms a 35-degree angle with the pole. So think if this is our pole here. We have a guide wire that's going down, that's anchored into the ground here. So it's with the pole, and that wire is 35 degrees. And that's a 20-foot wire. So find the height of the pole. We're looking for this one here. So if we follow this over, that makes our right angle. So from here, from this angle, this is the adjacent side, that's the hypotenuse. So we're going to do cosine of 35 degrees. So again, put your pencil on the angle you're working with. So then adjacent, opposite, hypotenuse. We have the adjacent, we have the hypotenuse. That's why we're using cosine. So adjacent side would be x. Opposite side would be 20. Take it times 20 to get rid of the bottom. So 20 cosine 35. And we get 16.3. Now they want to the nearest foot, so 0.3 is going to round it down. X equals 16 feet. So a right triangle has a leg of 1.5 units and a hypotenuse that is 4 units long. Find the measure of the acute angles. So if we draw out this right triangle. So we have a leg that's 1.5 and we have a hypotenuse that's 4.0. I'm going to call this angle A, this angle B. So we have these two bits of information. We could go through and find our third one, Pythagorean theorem, but we really don't need to. We can just use our trig functions. So first off, we would have sine of an angle. Sine is opposite over hypotenuse. So to get this to be opposite, we're dealing with sine of A here. So actually, I'm going to put an A with it. So we'd have 1.5 over 4.0 to have opposite over hypotenuse. The other side of this, we'd have to use cosine of that theta. So again, theta is typically what they use when using variables for angles. You know, let me just rewrite this. Let's write it this way. Sine A will equal 1.5 over 4.0. Just hopefully that didn't cause more confusion. Hopefully this simplifies it down to, okay, from A, this is opposite, this is hypotenuse. From B, this would be adjacent, this is hypotenuse, which is why we use cosine for B of, again, 1.5 over 4.0. Just like with tangent, if you're trying to find the angle, you use the inverse. So you're going to do sine inverse of the ratio. Over here, you're going to do cosine inverse of the ratio. So second sine 1.5 divide 4. So A would equal 22 degrees. If we do B now, second cosine 1.5 divide 4, which would round up to 68. So B would equal 68 degrees. Now, one thing that should happen, if you take 22 and you add 68 together, 22 plus 68, notice how we get 90. These two should add up to 90. So theoretically, if we find one, if you just take 90 minus that angle, that'll give you your other one as well. But I wanted to show you using both of these trig functions here. So that's it. That's the lesson. Any questions, comments, concerns? Please message me. Shoot me a message on Google Classroom, or my email is what I check the most. Another thing is you could send me pans, but notice I don't check those as often. Not on Sycamore as often, where I get the notifications on my phone for the other ones. So I can check that a little more. But until next time, talk to you later, guys.